Hello everyone, today I'll talk about the solution to the problem kth smallest in lexicographical order. This is similar to yesterday's problem, but the approach is slightly different, so it's not really necessary to have solved it. Again, in this problem we want to find, from all the numbers less than or equal to n, the kth lexicographically smallest. And n and k can be very large, we cannot go through all the numbers, especially not sort them, but also not in the way that we did in the previous problem. We have to do something smarter to find exactly this kth number. And of course, we know how lexicographically smallest works, and lexicographical ordering. We know that we'll start with 1, then we go 100, 10, 100, and so on. So add zeros, and then we can add a 1 at the end, and so on. 1, 2, and so on. So this is the approach that we want to take. And of course, after we run out of everything that starts with a 1, so for instance, we have a 19 and we have a 199, then we start with a 2, then 20, 200, and so on. So we're going to go starting from 1 until we reach the kth number, but what we want to do is to skip those large blocks. So for instance, if the final number starts with a 2, so it's 2 and something, we want to start with this 1 and skip the whole block of things starting with 1s that are smaller than n, less than or equal than n, until we reach the 2. And again, let's say that our final number actually starts with 22. Then we want to skip over everything that starts with 2, 0, everything that starts with 2, 1. And then when we reach 2, 2, we should go deeper and see if we should add something to the end. And in order to solve this problem, we can actually have a very powerful tool at our disposal, and that tool would be, given some prefix, let's say 2, 3, 1, to say how many numbers starting with that prefix are there in our interval from 1 to n. Because if we have that, that will allow us to skip some large blocks. So for instance, if we start by asking how many numbers with the prefix 1 are less than or equal than n. If that number is less than k, we know that our number starts with a 1. Otherwise, our number does not start with a 1. All those numbers starting with a 1 are before our number, and we can subtract their count from the remaining k. Because we've eaten those k numbers, they are before us in lexicographical order. And we can go then digit by digit to finally zoom in at exactly our number. So how do we count it for a given prefix? Well, at first we know that everything between our starting prefix and our starting prefix plus 1, not including this thing, is okay. So only this prefix. Then we know that if we add another digit, everything between our prefix with an added digit and our prefix plus 1 with an added digit, but not including this thing, is also okay. So this can be 0, 1, 2, and so on. Then we add another 0 to all of those options. So essentially we add another digit. And again, all of those are also okay, up to this thing that starts with the prefix plus 1. And of course, if at any step we overshoot n, we just have to cut out the top. So for instance, if this thing with a 4 at the end is okay, but with a 5 is no longer okay, because the value n is exactly this 23104, then we know that we can only go up to 4. And of course, at some point after adding this additional digit, we're already going to be bigger than n, and in that case we have counted all the numbers that start with our given prefix. And we can see it implemented here as a function that counts the numbers starting with a given prefix. So at first we start with prefix and prefix plus 1 as our boundaries, and they are going to become larger and larger by multiplying them by 10 by adding another digit. And at any step we take the right minus left, because everything between those is okay. So here, for instance, if we don't have this 4, everything between this and this is okay. So all the values that can be within here, and then after we add another 0, then everything between those two values is okay. And so we can add it to the result. Of course, we don't want to overshoot n, so if the upper bound is bigger than n, then of course we can take the n, and of course since our upper bound, our right pointer, is not inclusive, then we, instead of taking n, because we want to still count n, we want numbers up to n inclusive, we have to put n plus 1 here. Of course at the end we return the count. And now, since we can count the number of values starting with a given prefix that are less than or equal than n, we can skip all those large blocks as we talked before. So we start with the first value in lexicographical order, which is always 1. And now, while there are still some numbers to skip, we count how many numbers start with the current prefix. If the number of values starting with the current prefix is big enough that this whole block fits within k, we subtract that block and we add 1 to our current result, which means that we have to increment the last digit, and everything that starts with the previous digit will already be before us in lexicographical order. Otherwise, so if k is less than the count, so this block contains the number that we're looking at, then we know that this prefix is also the prefix of the number we're looking at. So we fix those first digits and we look at the next digit. So we just multiply it by 10. So as to look at the next digit. And of course that means, for instance, if we see that we're at 231 and we see that the number of numbers starting with 231 are bigger than the remaining numbers, we know that our number will start with 231, and also we have to now subtract from the remaining numbers a single value, which is exactly this value, this prefix without anything added after it. And at the end, we have run out of k, so we have skipped over all the values, we have stepped over all k values, so we can return the current value, because this is exactly what we're being asked to do.